Hey everyone, this is David D. Hilster. I am live tonight, Friday face to face, where you can ask me a question. We're going to talk about things, and you can even come on and speak to me live face to face. That's why I call it face to face tonight. And so, welcome everybody. Tonight, the topic is I will just put it up there for you. Uh, Dark matter does not exist. So if you are a person who has got your own theory, or you think you want to explain why dark matter exists, what it could be, I'm here to tell you that it doesn't exist. I'm going to spend some time showing you that. I do have a video about that already. So please take a look at that anytime. Just look it up. Dissident Science and Dark Matter Galaxy. But we're going to go over it today because I think even with that video, a lot of people are still thinking dark matter is there, and it ain't. And I'm here to tell you why today. Welcome everybody. Again, this is Friday night. I'm seriously thinking about moving this though to maybe like Sunday morning because the time frame here does not allow people in Europe to join, and I do have a lot of subscribers in Europe, and also I'm broadcasting to you today live to the Dissident Science channel. Excuse me, Dissident Science channel, and also the CNPS. So if you're a member of the CNPS, welcome. I'm here broadcasting live on Fridays right now between 9:30 and about 11:30. Depends on how it goes, how many people are here. And if you have any comments, you can, of course, uh, come on, type in your comments either on YouTube on the Dissidents, whatever channel you're watching this on, and I will go ahead and answer them. So I know as the night goes on, people will be joining us, and I welcome all my new subscribers. Tonight is a little different. That I'm really going to take a look at one of my previous talks on something that I think is really important. That it kind of gets me a lot of times because people, even in the distant world, talk about dark matter as if it's there. And I think the reason most people who are dissidents or have their own model or subscribe to a new model of the universe want dark matter or dark energy, which is even worse. At least dark matter has a chance of existing. Energy is, of course, a concept. It's not real. But if you are a dissonant person and you have a model you subscribe to, often you want to say, well, we can describe and we can tell you what it is, because that's a grand mystery. In fact, people are still waiting for the other shoe to drop because it's been told many times in the standard, in the mainstream science, that he who comes up with what dark matter or can find it, prove that it exists, will of course win a Nobel Prize. Usually now it's like the same year or the year right after it. But again, that is something that I'm going to talk about and try to get into your mind, that there is very good arguments of why it isn't there in the first place, and it has to do with everything with why it was predicted in the first place. So again, I want to welcome everybody from the CNPS and Dissident Science for tuning in tonight. And if you want to join me, you can. You can get a link. Let me put up a link here as to how you can join me. If you want to actually come on air, you can go to greenroom.dissidentscience.com, and you can get to this room. Give that a try. If it's not working for you, I can put in a link to. Excuse me. I've got something in my throat. It doesn't sound really great. Oftentimes I'm speaking too loud. How's my volume here? Probably too high. I do have a tendency to speak a little bit louder. I'm somewhat deaf from playing lots of samba drums all my life. But we're going to talk again. We're going to talk about the dark matter, and it all really stems from the fact that stars on the edge of the universe are reportedly go faster than they should. And because of that, we say, well, there's matter there that we cannot see. So I'm going to take a look and give you guys a little bit of graphics here that I had for my video. Again, dissidents, just look up Dissident Science, Galaxy, Dark Matter, and you'll get right to it. But I'm going to show you give you one graphic that will show you why there is no dark matter at all. So let me share you that one graphic you need. We'll talk more in depth about it because I actually have some pretty interesting papers and arguments to take a look at that were a part of it. But so let's take a look at this first graphic here. And this is a graphic that I made, and it comes from my talk about galaxies and dark matter. The galaxy above is a true galaxy, a true picture of a galaxy, and that is a galaxy which they claim that, of course, there was no dark matter. And it was sort of, how do you say, shocking to them because they figured dark matter's got to be everywhere. And why would one galaxy have dark matter and not? Well, the answer is quite simple. In fact, I've been accused by many people of saying that's too simple. They should know that. This would be, if it were true, everyone would know it, and then of course we would understand there doesn't need to be dark matter. But the things in life that we get wrong are mostly the things that are big, are the simpler things. So what you see here is on the top is a picture of a spherical galaxy. Turns out that there have been more than one spherical galaxy looked at, and this is what they call the second galaxy that they found that has no dark matter. Now it is spherical, and that is the entire answer. When I saw this, my jaw dropped open because I knew I knew that dark matter didn't exist, and I knew why it didn't exist. And the reason I knew that was because of thinking about the problem, and actually a paper that was written, and also my father had also done a talk on this at our. Those were published actually papers in our proceedings for the CNPS, the John Chappell Natural Philosophy Society, at our conference, and this when I saw this galaxy, it just hit me like a ton of bricks. I said, "You're kidding. This just proves my point very clearly, proves a lot of people's points, and that is the top galaxy is a real galaxy, and the bottom galaxy is a real galaxy. Those are two galaxies that are actually are photographed through telescopes. And the stars on the edge of a spherical galaxy are going at the speed at which they think it should. So their conclusion is, oh, there's no dark matter. My conclusion is it's a galaxy, and the stars on the edge, they're going at the same speed as predicted. That is great. You don't need dark matter for that. So it's missing dark matter, which is very strange. And it turns out that if you look at the galaxy below, which is a more common, well, I'm not sure if that's true. Before I get into trouble, which I'm not an astronomer, and I do know Halton Arp's Strange Galaxies. I have read his book, Seeing Red, I think it's called. So yeah, I do know galaxies come in all kinds of weird shapes and sizes. Well, this is not a sphere. A galaxy, and the Milky Way is not a sphere. It is what we call a spiral-armed galaxy. And if you look at the stars at the edge of our galaxy, the speed of those stars does not match what Kepler or Newton would predict for the mass of the galaxy. Well, the answer lies in what is in the blue letters. The top one, the galaxy, is a sphere, meaning the gravitational field around this galaxy, which is just bunches of stars, is going to be the same in all directions from the center. Whereas in a spiraling armed galaxy, a spiral galaxy with arms, is not a sphere. Its gravitational field is in no way a sphere, although people calculate it like that. And when you make what do they do to calculate the speed of stars? Well, they certainly don't put a model of a 100 billion stars, or how many they are, in a galaxy and give them all gravitational fields, and then calculate how that would all swirl around. And they should do that because they're going to find that they're not going to need dark matter. Well, they say, okay, I know how many stars. We're going to estimate how many that is. We're going to estimate their average mass, and then they're going to put it as a point mass right in the middle of this spiral galaxy. And of course, again, what they do is they treat all the mass as a point, and they make it a sphere. That is the amount of you can easily graph that, the amount of gravitational pull will be equal in all directions. They think that's what they say. Of course, that's how they calculate it. They don't. I don't think they think about it. And when they do that, they in fact find out that, oh, according to that point mass, which would be a spherical galaxy, not a spiral arm, but that doesn't seem to bother them, that the stars on the edge are not going at the predicted velocity. Therefore, because it's not, there must be things that are missing. And of course, in the way you earn Nobel Prizes is to predict something that you can't see or didn't know was there, and to find it. Because when you do that, you become famous. They name something after you. You get $2 million or whatever the prize money is for the Nobel Prize. So this is what's going on with the dark matter. This is why you have dark matters, because they calculate the gravitational field of a non-spherical galaxy, which has a non-spherical and very irregular gravitational field. They don't take that into account. They calculate it as a point mass, and they go, oh, look, the edge galaxy. Of course not. All the edge stars are going at different speeds. Of course they are, because the amount of gravity in line on the edge of a galaxy is quite different from above, and so that the mass, when you look at the actual gravitational field around this, it turns out that, and we have people who've calculated that, actually one person in particular who's done actual calculations using Newton, that when you take into account the non-spherical nature of a galaxy, that in fact there is no anomaly. The stars match the right speed that they're supposed to be going at. And of course, then if that happens, there's no need to pretend or invent dark matter. So that's how that is working. Here again, I'll take a look at this a little bit closer. This is the predicted speed matches in a spherical galaxy. Let's take a look at, well, Dave, yeah, you can make a point mass. It works pretty well. Well, take a look at this one. This is not going to be a spherical gravitational field as well. We know because there's more mass on the ends, and it's not sphere at all. So the gravitational field around these objects are not spherical, and you cannot treat them as such. And when they put the above sphere, it has no gravity in it. Okay, the above sphere. So I'm imagining he's talking about this one here. There is no gravity, no galaxy in it. This is a okay. Zeben 64. This is a picture from a galaxy. This is declared a galaxy. The number of stars in it are the number of stars in this galaxy match other star counts. And in fact, yes, it is considered by mainstream a galaxy. This is not my picture. This is not something I'm inventing. It comes from mainstream. So that will answer that question. To also give you an idea, yes, I understand. You're saying the before slide, this slide here. Yeah, you're saying the above sphere. It's not a galaxy. Yes, it is. You can't see it. I mean, very easily because it's all spread out. It's very spherical. It's very uniform, but that is the same as this. Yeah, it's the same. You can just see this is exposed more. This is classified by astronomers as a galaxy. So I'm not coming up with that my own there. Okay, and let's take a look at a non-spherical gravity, non-spherical gravitational fields. Ask people at NASA or from anyone, if anyone who is sending anything to the moon and the Earth, does the gravitational field for the Earth and the moon equal the mass of both put at some center there, and then you calculate speeds? Absolutely not. I mean, there's all kinds. Here are just two orbits I just sort of drew. One would go in between. Obviously, the gravitational field is different all over the place. In fact, they have a two-body system. It gets very complicated. And so we know just from our space travel of sending probes and people, in this case, men to the moon, people to the moon, and we're going to be doing the same to sending people Martians. We're going there. People will live on Mars. hopefully maybe they will come back, whatever. They those fields, as you can see, between all of these, there's tugs that when the Earth's going around the sun, the moon tugs on it, all the other planets tug on it. The gravitational field is not spherical. And so that is again why we have this problem. Now this is really interesting. This is from my father's talk from the CNPS. He gave a talk at one of the conferences, and you can see the blue line and the red line. The red line is the Keplerian predicted velocities. Why is this going up like this? Well, it's because the mass of the galaxy is calculated in such a way that it's spherical, and so everything is nice, smooth curves. But when you actually look at the speed of the stars and the distance from the galaxy, you can see the measured star velocity gives you this curve, not even close to the Keplerian prediction. You can see where our sun more or less stands in the galactic field of the Milky Way galaxy, and this is a distance of light years from the center of the galaxy. So you can see this, and what's interesting here is that you can see from the speed of the suns or the stars that you can actually see the arms and the spaces. When you have the speeds are lower, that's because they're in an arm. If they're a little higher, the space between the arms. So those peaks at the top you see represent more space and less stars. And you can literally see the arms of the galaxy in there. What does this mean? Well, gravity isn't working the same, and the speeds of the suns are not the same depending on where they are. Why is that? Because in the arm there's more gravitational field because of all the stars than there are in the space parts. Now, this by just looking at this, you can make that kind of conclusion. Again, my father did a talk on this. You can go to the naturalphilosophy.org. Let's see if I have that somewhere here. Yeah, go to naturalphilosophy.org and look it up. I believe you can also find it on our wiki at naturalphilosophy.org, or you can find it in a paper in our database. But you can go there and see this and another paper I'm going to be showing you. So, so you can see you can in fact get an idea that, well, the speed of these suns have everything to do with the amount of mass around it, and that varying mass in a spiral galaxy, and these speeds can be described, actually explained by that. Why are you needing dark matter for such a thing? And you don't. The rule is if you don't need it. Of course, there's I've got lots of slides here talking about, of course, people's the magic of dark matter, and our science evangelists like Neil deGrasse Tyson, who thinks he's God's gift to the universe and whose ego is more important than scientific truth. So again, going over this predicted speed, it does not match. It's not a sphere. And this is a galaxy that looks like our galaxy. And if you are going to tell me that the gravitational field around this galaxy is the same in all directions, I'm going to tell you a little bit crazy. And not only that, I'm going to show you some calculations. We're going to get to those. Let me go backwards. I can see that. Let me go backwards. I'm going to get something from Cameron's paper, Ribisol paper. So I'm going to go back real quick. Here we go. Oh, there's my father giving a talk on the. Let's see if I can make this bigger. Yes, I can. Oh, dummy me. I can always make it bigger. There's my dad talking at 2 years ago at the CNPS at the University of Connecticut, talking about visualization in the galaxy using the blue curve. You can literally see that blue curve. This is from his, if you look up CNPS Galaxy, Bob D. Hilster, 2018, he gave that talk 2 years ago. And there's also this one, which is by Cameron Ribigzo. I can't get that right. But that is a paper that you can find on our wiki. Again, I can put that up. That is this. So you can look this up. Look at Newton's gravitational law over dark matter. What that title means is that, in fact, the Newton's gravitational law works totally fine to describe the what is supposedly anomalous movement. There's nothing in the universe that's anomalous. We just have people that are not understanding the universe. I do see you, science thinker. Stay there. I want to go through this first, and unless you want to stand by and talk about it with me, let me know in the chat. But I will bring you up to talk. We do have a couple hours that I'm usually here. So getting back to this, Newton's gravitational law of dark matter, you can look that up on that website that I have right there. Let's see if I can make this bigger. I can. So this is one of his figures. And what he's doing here is basically saying, okay, we have arms in the galaxy. I'm not going to make them curved or anything. I'm just going to make those rectangles. And I'm going to start calculating the mass and the pull of mass using Newton's laws by breaking down the galaxy into smaller pieces. And that's what he's doing here. Let's see, can I go to the next one? I think I have to shrink it back down. Hello, come on. Oh boy, how do I get... It's not going to want to go to the next one once I go up to the top. Come on. Hold on. Just trying to get... Oh, there we go. All right. We'll just do it that way. We'll leave it this way because it'll work. Here is his final calculations. Let me get this out of the way. In his paper, again, his paper is on this address right there. You can take a look at it. Newton's gravitation over dark matter. He broke down the galaxy into something like this. It's trying to simulate a galaxy with its arms, and each one of those is a mass, and he was calculating, and he did calculations of the speeds of C, B, and A being the speeds of the suns. And his conclusion was that when you break down and you make a non-spherical gravitational field that's sort of like a spiral arms, that in fact, and he's trying to, again, simulate as close as he can, that when you do the calculations, lo and behold, Newton says that these stars should be going at this rate, which is not the rate as predicted by a sphere. It's at the rate, it predicts that they actually are going faster. I believe that's what is happening. They go faster than they're supposed to, or slower. Don't quote me on that. All that matters really is that the Newton's equations applied to a non-spherical, very similar armed kind of mass, gravitational mass, in fact shows that no, there is no anomalous. The anomaly comes from us dumbly, stupidly applying, graphing the gravitational pull of a galaxy that is not spherical in nature, and putting all the mass in a point, which becomes a sphere at that point. The moment you treat a galaxy as a sphere, it's over. So can we go to the next one? I think if I do this, yeah, it seems to be like when you do that, it resets it. Oh, come on. No, it doesn't move. I'm sorry, guys. This isn't working out. I will see if I can get another one here. Do we need Rigorous-Sol? Okay, I'm going to get one picture of him because he is. It was important for him to and I want to show you some of his equations before we see if, in fact, we maybe have some conversation with science thinker. Okay, here we go. This is from 2016. In fact, 2 years before. I think this is at the University of Maryland, and he was giving a talk And you can see there he doing some calculations. So you can see his gravitational fields and how he was doing the calculations. He shows all his calculations in the paper to give you an idea how that all works. And in fact, he ends up saying that the stars are not going at the wrong speed. They are going at the right speed when you do the right calculations when applying Newton's gravitational law and applying that to something that is non-spherical. Okay, let me see here. I'm going to go back now. So I hope that was informative to you. Gives you an idea of how that works. Let's see. Why do galaxies look like a flat disk if they are more of a sphere? Well, they don't. They're not a sphere. That's the whole idea. All of them are not spheres. The ones that they find that are spheres, they find out that again, it's not dark matter, folks. They're not calculating dark matter. There's no dark matter formula. They go to a galaxy, look at the speed of the stars, which they can measure over time, and they go, oh, according to Kepler and the mass of this galaxy, which we're going to condense to a point, which means it's a spherical point, it's equal in all directions. Those stars are going at the right speed, so there's no dark matter. Well, there was no dark matter if you begin with, if you would have calculated Newton's gravity according to the right gravitational field or made models in a computer to find out that, in fact, they're not, there would have never been even the notion of dark matter or dark energy. Energy is a concept, so it's even worse. So energy, there isn't anything in the universe that's energy. It's a great concept, useful concept, but it's not real. Let's see what he says here. Sounds like gravity is a thing embedded in matter and not space-time. Well, gravity has to do with matter, but you have to have a model for your gravity. There's the Lesage gravitonic model. There is several ether models. There's quite a few ether models that try to describe what gravity is physically. They all have to do with particles or mass causing that. It's a push. Gravity is a push. So most people outside the mainstream science think that. It says the stars and galaxies move like a wheel, faster on the outside, slower, closer to the center. Well, that's true, but it's actually not just simply that. It's also the mass that's in between them, and that actually causes them to go at a speed. Not because, but that would be saying all the stars move in a spoke. That if you drew a line from the center of the galaxy all the way out to the star, that all stars that are on that line will move together around the core of the galaxy, and that's just not true. And and the speeds at which they think that they're traveling aren't traveling at those speeds, and that's why they did the gravity. So here's another ops gravity. Gravity. I meant is tied to electron density. Oh, I think that's what I said. Yeah, I'm sorry. Yeah, okay. So you're saying that gravity is tied to electron density. Now I'm guessing maybe, are you an electric universe person? Again, electron density, you have, so you would believe in a field. What is that field actually? I'm always asking people who believe in electric universe, what's an electric field? We have a model where we have everything is modeled. There is no fields that have no, again, if you are electric field and charge and electric fields, you do have to tell me what those are, because you can give me a system. There are many systems that can describe this. Space-time can actually describe it, but does it mean that's what's really there and that's what's doing it? A spherical galaxy is larger, Z pinch, than most Birkeland currents of most galaxies. Again, if you're talking about that gravity is caused by electric, my question to you is, what's electric? So if you're going to say gravity, I want to know what's your model of gravity. If you're going to say gravity is caused by electric fields, electric force, I want to know what that is. That's just, well, that's one of the basic things of the universe. No, I'm not going to be satisfied with that myself. Not saying that electric universe is wrong or anybody's wrong. I'm just saying We just don't want to swap out space-time for electric fields, and you go to the person on the street, and I'm the electric universe person, and the person next to me is Einsteinian person and standard model. The Einstein guy says, oh yeah, gravity is space-time and it bends. Well, what is it? Is it a fabric? Is it foam? Well, we call it it's like a rubber. Yeah, you don't know. The guy doesn't know. It's tensor equations. And then the guy says tensor equations are real, and people are going to look at him like you're nuts. Then you go to electric universe people and says, well, no, it's not caused by space-time continuum and space-time and the curvature. It's an electric effect. And the person goes, oh, okay, well, how does that work? And you may have some explanation, and they go, okay, but what is an electric field? And again, you're in the same place. All you've done is swapped one system for another without any physicality still. And I'm one of those people that I just not going for that anymore. And we have people working on models like my model. There are other models. Borkert has a model. He hasn't worked on it really for that detail. Yonel Danu and Laurie Gardy are working on an ether model where they're trying to actually say that well, they don't have charge either, but they're trying to give physicality to do all these things. And I think that's we have to do that. We're to the point we got to do that. We're tired of the 27 systems that work and no one knows what it is, basically. Gravity is created by gravitational producing bodies such as a star, blah, blah, blah. Through its structure and mechanism spin. Earth's magnetic field is a gravitational field. Again, what's a magnetic field? So if it's not, it's gravitational field. So a magnetic field, gravitation, what is that? We still have to answer those questions. Again, what we have a lot of is explanations of systems, equations. We're not saying, when we say field, this person, Ephraim, you're saying field, and gravitational field. What is that? We have a model, and we can tell you what a gravitational field is. We can tell you what a magnetic field is. We can tell you that what we consider an electric field is actually another gravitational field of smaller particles below. Whether you buy any of that or not, you think that's a bunch of baloney. We have a physical model. And in the end, if you hand that to an average science lover, they're going to always opt for something that's real, that they can say, oh, that's what it is. There are particles moving like that, and you call it that, and I can see how that could work. Whereas if you have mathematical equations for fields, then of course that's going to be a lot harder. The guy dropped out again. Maybe people are dropping out. So I'm sorry about that. I hope he comes back maybe. Want to again welcome everybody. I've got people from the John Chappell and also Dissident Science YouTube channel. I'm Dave D. Hilster. I am actually one of the members of the John Chappell Natural Philosophy Society. Our goal is to support everybody working outside of mainstream that's doing serious work. What is serious work? Well, you can pretty much look at serious work because it has all the telltale signs of scientific method, and we allow people to come up and give talks, to write papers, and that's what that society is. And it's really great to have people from both that channel and my subscribers on board here tonight too. They seem to be held in a place by dark mode energy. I'm not sure what that means, but let's see. We spoke last week, David. Yes, I'm into the shockwave. Oh, okay. Yeah, I think we speak here from Canada, I believe, right? And you also follow, I think, Laurie Gardy. Okay, I have Science Thinker on. Now, I'm going to bring you on. Here are some of the things that we need to know if you want to come on. Again, if you do want to come on board, we have room for 10 people in our green room. I call it a green room. I don't know. It's using a waiting room is basically really what it is. But you can go to greenroom.dissidentscience.com. You can come in. What you really need to do is have some earphones, and you have to have a microphone. Almost everybody has a microphone, but having the earbuds, you see them, I have them here. And what that allows us to do is talk without having echo, because what I hear from here will not go through my microphone. So I'm going to bring you on, and hopefully this will be a person that will be interesting to talk with. I do not know this person, so we're taking a chance. If I find out this is person's not a polite person or something, I will have no problem of dropping them off. So please don't be worried about that. And but I'm also open to discussion. What I do like to do is discuss with people, and I don't. One of the things I just want to make up right up front is telling me how things are and not having a discussion is not. I'm not so interested in people preaching to me anything or some idea. I'm really more interested in discussing science and back and forth. That's why we have the live sessions. So here we go. Um, Science Thinker, we're going to bring you up here. Hey, how are you, Science Thinker? Can you say hello?
Hi, David.
Hey, how's it going? Oh, you're coming out the wrong speaker. Let me see if I can get that. Hold on. Okay, yeah, I got to get you off of that and onto my AirPods. Okay, okay. Can you say hello again?
Hello.
Hey, okay, you're in my earpods. You're coming through my speakers, and that probably caused a massive feedback. I appreciate you coming on. Thank you so much. Tell me a little bit about how you're interested in and why you're here. Are you here to save me? I'm kidding. Are you here? I always like to know because I will say this: the average science lover it does not make their way to dissident science, and especially talking to a person like myself. So tell me a little bit about your dissident journey. I have no, how do you say, I respect everybody's journey, where they come from, even if you have totally different kind of ideas. So go for it. Tell us a little bit about yourself.
Well, I found your channel because you seem to talk about a lot of the things I'm interested in. I've
Oh,
been studying the philosophy of physics, the history of physics, watched a lot of those lectures. I'm interested in a lot of the plasma cosmology stuff, expanding Earth as well.
oh,
But
okay.
yeah, really looking at the philosophy of physics and seeing where things went wrong. And
Oh,
yeah, Einstein, a lot of that stuff. So a lot of the same interests, really.
oh,
So
okay,
yeah.
okay. Well, that's really good. You know what's really interesting in what you said is something that people don't understand. And one of the things we do is we don't call our group a physics group. We call it a natural philosophy group. And people, it's hard for people, especially people who are more, oh, what's the physical world about, to even mention or even talk and use the word philosophy. And philosophy is extremely important in science, and not as many people really even, like I said, mention that. Tell me a little bit about what the philosophy you mean by philosophy when you use the word philosophy.
Well, metaphysics and epistemology, and I actually saw there's a lecture series. I don't know if you've ever seen it. It's on YouTube. It's called "The Philosophic Corruption of Reality slash Physics" with David Harriman. It's a
Oh, I've not heard of
five-part.
that.
Yeah, you might be very interested. If I don't know if I could
Sounds
send you
like
the
it.
link,
Okay.
but he goes over the history. He's a physicist by training, I guess his degree or whatnot, but he studies philosophy. And yeah, he goes through the history of physics and the various physicists slash philosophers. Some of them were actually both, I
Right.
believe.
Right.
And I think um, he gets up to Boltzmann, for example, and speaks very positively of Boltzmann, I believe, and then very poorly of some of the Boltzmann. I think kind of got extremely depressed, and I think he might have killed himself because he couldn't stand the way that physics was going.
Yeah,
Um,
that's a shared feeling these days for sure. And also the thing is too is you have to remember that physicists and physics were not words in our vocabulary until just recently. People were called natural philosophers, and those people were looking at the philosophy of nature. And so that's why you have Principia Mathematica from Newton, and the it says natural philosophy. It doesn't say physics. He was never called a physicist or a physics person. So in the idea that is physics is a very new notion. Go ahead. I'm sorry to interrupt there. So you were talking about the philosophy. So you watched this guy's, and he was saying Boltzmann, and then other people he was talking about were he wasn't such a big fan. Who were some of the people he wasn't too keen on, or you
I
don't remember?
I'm
I'm
not
putting you on
sure.
the spot right now.
I think. Well, he brought in Kant, I believe, Immanuel Kant. I think he had.
Okay.
Um, I don't remember all the other names, but he does get up to Einstein and then relativity and all that
Right,
stuff. So he
right,
gets into a lot of the things you talk about, and
right, right, right.
curvature of space he talks about, of course, and then like Schrodinger's cats and all that kind of stuff. So,
Mhm.
but yeah, I'm very interested in the topic you're talking about today. But I actually wanted to ask you a question about
Sure.
expanding Earth,
Oh yeah,
and
sure, sure.
I know you've talked about you've brought Stephen Hurrell
Yes.
on before, and you talked a lot about his books, but there's somebody else that you've never mentioned that I discovered. Um, Peter Woodhead. Have you ever heard of him?
I don't know. You know what? In fact, that is that in his book in I have this book here. That is that in here. It is. Let me see if that's in his book. This is, of course, his book. The big, first of all, just so some people know who are not familiar, this to me is the most important geological book ever written in all of the history of mankind. This is by James Maxlow. This is a real geologist writing about expansion tectonics to the max. This, in my opinion, 100 years from now will be a Bible. So that's that one. But you're talking about, let me get his name because he has 19 people in here, I think. Wood, you're saying?
Yes, Peter Woodhead. I haven't read that book, so I don't know. I don't have that
Okay.
book, but I found two
Yeah.
videos on YouTube. They're actually dated from 2014, where there are interviews, and I can send you links to that.
Yeah, it would be very, because it's not even in here. I would imagine probably Stephen Hurl would, he probably knows about that. But so you watched him? What
Well,
was it?
the interesting thing about Peter Woodhead, he seems to have done a lot of very in-depth calculations and research,
Right.
very in-depth mathematics on gravity. But the big thing about him that was different is he came up with a model that will allow for expanding Earth without any mass increase at all.
Mm, okay.
So, and
Now, right. Go
that
ahead.
was his big problem when he was looking at it. He wasn't sort of buying the potential explanations for mass increase. So he tried to think, do we actually even need a mass increase to cause a gravity increase? Not just the expanding Earth, but also, so he's shown that you can actually have a gravity increase and a volume increase without
Hmm.
any mass increase, simply through a change in the distribution of mass.
Hmm.
So he's what he's claiming is that there were some wrong assumptions about the center of mass for the object
Hmm.
for Earth, and that if you actually do the correct equations correctly, that merely have for somebody who's on the surface of the Earth is very different than being away from the Earth. And if the more of the mass is towards the surface, that actually will increase the as opposed to the center, and that
Hmm.
changes. That will actually increase the gravity on the surface of the Earth for somebody on the surface as opposed to further away or
That's
something.
interesting. I would have to really look into the calculations of that to see, because right now my intuition is I'm not going to rely on on that. But that's very interesting. So I understand what you're saying is the Earth isn't. He's saying the Earth expanding, but it's also pushing its mass out toward the edge, and then there's less mass in the middle, is what he's saying. Is that what you're saying?
Yes, and I believe the proposed mechanism, I think he's saying, is nuclear decay or whatever
Yeah, yeah. I
heating.
mean, I think one of the things that at least I also subscribe to is that I don't think the exponential increase of the radius of the Earth, which is happening, the graph of it's like this, right? And that's been calculated in various ways. So the expansion is not linear in any ways. It really went very, very slow, like inching along, and then it's really picking up speed now. I do believe there's probably some, how do you say, nuclear kind of action going on in my opinion, in the center of the earth. Now, so okay, so what I would say is that the thing that would, in my mind, say that would be right or wrong would be, is it the case that our evidence for a very solid, heavy center of the earth, even today, is that something that we have real evidence that I would believe that when geologists say the center of the Earth is made of iron or whatever, that we would have, I don't know if earthquakes or how far down we can see or what kinds of, calculations or ways they calculate that. So my just looking at that, because I'm totally new to that idea, I would say the thing that would make or break that idea will be that if there, uh, first of all, gravity, has been bigger. There's two things I think that could distinguish either that idea, Wolfhead, was this Wolf? No,
Woodhead.
Woodhead, Woodhead, his idea, uh, instead of a mass actually increasing coming at a subatomic level, for instance, would be, do we really have very solid evidence, pardon the pun, of a really heavy core of the Earth? Is there something that's going on that would tell us that? And the evidence is pretty good. The other thing would be, too, is that, oh gosh, what was it? Let's see if it's in the center. The other would be is the calculations for what he's, oh, no, that wasn't it. If there's geological evidence of mass increase, not geological evidence of a gravitational field. So we have, I know that James Maxwell, who I consider the number one expansion tectonist in the world, in history at least, even more than Samuel Carey, I spent a week with him. He was at our conference, was given an award and all that stuff. So I got to spend some time. And I know he, even 10 years ago, came to us, was wanting to say to us, look, there's mass increase. I know it's happening. So my question to him would be, is there geological evidence of mass increase? Not bigger G. Now, if you look at Stephen Hurl or Hurl's, I think it's Hurl, Stephen Hurl's work, it is on the gravitational field. But if it's the case that there's geological evidence for mass increase, and I don't know what that is. Right now, it's more of, has the gravitation been less or more? So I perfectly understand what his hypothesis is, and the way to tease those apart would be to look at those two things. And not only that, I would imagine that somebody in our group who does like that topic, I would even perhaps take it on. But I know one person actually. I know if I send this to him, he'll write a paper for it instantaneously. He's a really good engineer, and that is, oh man, my names are going by me. But he's actually been doing some talks on the electric universe. He was with our group for 5 years. We didn't have our conference this year because of COVID, but he's been making some videos of his work. Gosh darn it. Anyways, he is an engineer. He always says, I don't have any of my ideas my own, but I will test anybody's hypothesis. So he would probably come up with a paper saying, yes, that's possible. But again, the way I would say it is you got to tease out by looking at, do we have geological evidence for actual mass increase? Not G, just mass increase. Are geologists getting reads in geology, ancient geology, that says no, mass has been increasing? The second one would be, do we have really, really strong evidence for a heavy core? So I will tell you, I cannot say to you that that's wrong or right. I can't tell you that either one is wrong or right.
He gets into the core part. I know he looks at seismic data that would back up the core being less dense.
Right.
How can I send you all these links so you'd be able to look at it?
You can just send it to david@dissidentscience.com. It'll get it there. I'll get it.
Okay, wonderful. Well, then I'll let you continue.
Okay. But if you want to stick around and talk, but again, have you looked into the dark matter? Or have you been here since I started talking about it?
Yes. I've heard it from you.
Mhm.
Yeah, if I remember using Newton's equations, and
Right.
you shouldn't need the dark matter. That was something I'd been skeptical of long before I'd even heard these explanations for
Right.
why you don't need it. I
Yeah.
was interested in redshift things as
Right.
well, and
Right. Right.
so many of the same things.
Okay, I got you. So you were like myself too. Anytime you see dark or spooky, you can. I always look at it and go, "There's a really good case that this is not the universe being dark or spooky. It's our own models having big problems and describing things." And in this case, it's pretty interesting. I think the thing that's about dark matter that's so interesting to me is that it's not really. How do you say? It's not something that it's the absence or when you look at a galaxy and says it doesn't have dark matter, and you then look at you saying, okay, these stars are going at a different speed, instead of saying, well, maybe let's look at how we're getting this. I think the reason is it doesn't. It seems that they went super fast to a dark matter, and I think the reason that kind of tendency exists in mainstream science is because the people who go into it who have to swallow a lot of things that you and I wouldn't accept and wouldn't we would not stand in front of a room full of students and say this what I'm telling you is the absolute truth in science. I think these people are more they'll go along with things to stay in their positions and all that. So they're going to say, oh, the way we become famous is like, oh, an anomaly. There's something there that we can't see. If I find that's something we can't see, I'll become famous. I'll get named after. I mean, that sounds like a stupid and cynical reason, but I really do think that that's why they didn't go. And because I would look at it this way: if you took NASA engineers or SpaceX engineers, people were dealing with real things. You can theoretically talk about things all day long, but you're going to make chemicals have to have a push and they have to do calculations and all those things. If you were to give them that problem, they're going to say, oh, well, the reason this rocket isn't taking off is because there's some mysterious material holding it down. They just laugh at you. What they would look at is the speed of the on the edge of the galaxy. He says, oh, we've got Newton's law. Maybe we're not doing this right. That's where the mistake came from. Instead of saying we're not doing this right and then saying, well, maybe, oh, wait a minute, it's not spherical. Let's put this in a model. Oh, no, it's okay. No dark matter. Well, the whole idea of wanting and having dark matter, of course, is much more prestigious than not having it. And so I think that's one of the reasons why, I think so many of us are skeptics about, dark matter. And of course, energy, of course, isn't at all real. You can't put it in your hand. It's a great concept, but so okay. If you have any questions at all, what's your name, sir? Or do you haven't? You don't want to use your name, Science Thinker?
Oh, I'll just stay anonymous for now.
That's fine. Okay, I'll call you Science Thinker. So, if you have any questions or comments or something you want to discuss, you can let me know.
Are you also familiar with Eric Lerner and the Big Bang
Yeah.
didn't happen? I'm not sure if
Yes.
you've mentioned him. I thought you might be.
No, I didn't mention him specifically, but I know of Eric. Yeah.
Okay.
I think it's not his only work though. I think he was sort of a dissident thinker, if I remember
He's
right.
working in fusion, dense plasma focus fusion device.
Okay.
Um,
Okay.
there was also a short documentary called I think it was Cosmology Quest or something. The Big
Oh
Bang.
yeah,
He was
I
featured.
know. You want to hear some stories about that? I know the director. When I
Oh
was
yeah.
making my film, I had a long conversation with him because when he got done with his film, he said he used to sell it. This guy is a really interesting guy. He is a very well-paid, very wealthy man from writing. He's an American living in Italy who writes music scores for films. And he got into cosmology and he read Halton Arps and he got into that and saw what was going on. And because he had the funds available, he decided he was going to make this documentary. He unfortunately, when it was done, he said if he had friends over to his Italian villa, he if he wanted them to go to sleep, he would show them the documentary. And he says, David, for goodness sakes, make it interesting, your documentary, which I did. My documentary is, even if you don't into Einstein or even physics, it's still a very interesting story. So I talked with him, and he basically got as many of these people, and he did a great service to have a lot of these people talking about the Big Bang and the problems with the Big Bang. He spent a lot of money on graphics. He has the graphics he did at that time were pretty expensive. It's not like today where you can do it very cheaply. But he did it, and then he just couldn't get it out there. No one was looking at it. He didn't know how to market it. He didn't know how to get those ideas out there. So it sort of died a slow death. But it's still out there. I think you can now see it online. He doesn't. I don't even know. His name's Randall somebody, but very interesting character. Very interesting character. So yeah, I'm Randall somebody, but or somebody Randall. I think Cosmology Quest. But anyways, yeah, I've heard of him. And the Big Bang, for those who are here listening in today, the Big Bang came from the 1930s. Actually, when we were in Flagstaff, I was in Flagstaff, Arizona for the 1996. Ooh, wow, 24 years ago, I was at a conference, the MPA conference, and I got to see Lowell telescope in the Lowell Observatory. And I believe it was from there people were seeing redshift, and they also then, if it was redshift, they thought, oh, that's movement. If it's movement, then it would be going away. If it's going away, then the universe is expanding. If it's expanding, it had to start. Big Bang was a derogatory term which ended up sticking to it, and so the Big Bang has become the sort of default cosmology, overall cosmology, how do you say, paradigm for the last almost 100 years. And of course, there's just so many problems. If you're talking about philosophy, you have real problems. And if you talk to people who claim to be able to explain the Big Bang according to the standard theory or standard thoughts and ideas, philosophy, and that is the universe was very small and then expanded into space, but it didn't really expand into space. Space expanded along with it. Now, if you think about that philosophically, there's absolutely huge problems with that, because if you have a size, how could you have size if there's the universe is all into this one place? What's around it? How could it be somewhere? It's just an absurdity philosophically. Of course, then you have the problem of why did it start? You get into crazy ideas that there are parallel universes that have these long, like, membranes, which they call brains, and that Big Bang start by those things touching, and when they touch, it sets off a Big Bang. It's just one absurdity after another, and of course, the idea every time we've gotten a bigger telescope, the universe was millions of years old in the beginning of the 20th century. As the 20th century started, in the first couple of decades, it went from a million to 10 million to 500 million, then to a billion. And every time we got a bigger telescope, it got older. And now it's down, and you won't believe it. Look up the Big Bang in the Wikipedia, and they'll tell you, well, we've moved it this year from 13.87 billion years old to 13.89, and here's the reason why. It's just really crazy. And of course, the answer in our world of people who look at this is that the idea that light or anything can travel through the universe unimpeded, unaffected, and without stop at the exact same speed doesn't make a whole lot of sense. So the idea is that because we have no model for light, and our model for light goes infinitely, for infinity at the speed of light with no change, that of course then, the redshift could only be movement. But in reality, most people who are outside mainstream will say, they'll call it what more or less people would call tired light. That is, light as it goes further and further will redshift because it's traveling long distances. And that's one of the reasons, and there is a good philosophical reason for that, and that is, how is it that we happen to be on the earth, and everywhere we look in every direction, everything is redshifting. And of course, they've even been crazy enough to say that everything's expanding and everything's expanding. So everybody in the universe is always going to see it gets crazier as you go on. So those who are not into philosophy, the Big Bang is just destroyed by philosophy. No, there's a couple of people who are very good at arguing against the Big Bang who are alive today. Two of those people are George Coyne. He wrote a book just recently. I can't remember what it's called. I think Consciousness. George Coyne, Coyne. He was at our conference in 2018. 19 was at the University of Washington. 2017, we were at the University of Vancouver to have our conference. And I think he gave a talk there. So the other person is Glenn Borkert, Dr. Glenn Borkert, who's very well known for his ideas on infinity. I suggest everybody read that book, The Infinite Universe Theory. I subscribe, our model subscribes to infinite universe. I cannot believe there is a one particle that can make the entire universe up out of it. That's what the standard model tries to do. And Stephen Crothers. Oh, yeah. Yeah, there's a person. Thank you very much. The next poetician. Oh, I like that. That's pretty cool. Stephen J. Crothers. Absolutely. He actually takes the. Oh, no, that's black holes. But I think he also does the big. No, that's the big bang, black holes. He's more of the black hole guy. But he's also doing Big Bang. I think he's also doing special relativity. So, yeah, I'm sorry. Mixed up that with black holes. If you are skeptic about the way black holes are described, just look up Stephen Crothers. Very interesting person. So let's see if we have some thing here. Cosmology Quest. Randall Myers. Oh, music by, of course. He scored his own musician. He's a famous Hollywood composer. Randall Myers, unless he moved to Hollywood. I thought he told me at the time, but that was 15 years ago. He was living in Italy, but he may, in fact, I'll have to look that up. Mr. Randall. I'm sure I saw my film at least. Let's see, Randall Myers, composer. Is he on IMDb? Up there he is. Yeah, but Randall, you got to paint your hair like me. He's getting to be gray. There he is. Randall Myers. He looks like he's still living in Italy. Composer. Yeah. Except, not sure he is. I think he looks still, unless his stuff is really old. But I think he's still in it because he's got a picture of his Italian villa with. He was telling me, oh yeah, I bought this dome from this that was being destroyed by some ancient thing, and I bought it and I had it shipped here and getting it stuck on top, and that's the picture on his. Hey, okay, no hair painting, all natural. Well, I will tell you, see my hair? It would be mostly gray. Well, my wife is a Brazilian clothes designer, not famous. She just does that as more of a hobby. She does Brazilian costumes and stuff. Very talented, actually. A lot of the clothes she'll make for myself. But she will not let me let my hair go gray. So, how about that? Let's see, what else here? Hydrogen origin theory of the universe is my theory on the origin of the universe. It started with hydrogen atoms. It is a theory that originally of the universe is not expanding. Okay. One thing I would say, if you want to know my opinion, and again, it's just my opinion. The only thing, maybe the difference I have is I've been around a lot of people and a lot of people who are dissidents since 1992, almost 30 years. So I've hung out with critical thinkers for quite a while. My feeling is that the universe is more soup-like and in cycles, not the whole universe, but cycles belong. I don't believe in the universal cycle theory either myself, but I do believe. Here's the reason why. This is the simplest. When I talk to people and they go, Dave, the average person, not people like you who are actually here listening, most of you are science lovers and really are into all this. And that's to be praised and read books like I do. So we're all very similar. None of us we all know something that other people don't, obviously. But one of the things I I notice is that when a person asks me, I have this explanation for the average science person. They find out I'm writing a book on the universe model and all that stuff, and I have my own YouTube channel. So they go, "Oh, Dave knows everything about science." Of course, that's not true at all. So you become the science whiz even if you're not. And so I get this question from lay people who like science, and one of them says, "If it's not the Big Bang, what is it?" Well, I say, well, when you look up into the sky and you've read about the sky, things that we see with telescopes, do you see the birth of stars? And they go, yeah, yeah, I've heard about that. Do you see the death of stars? Yeah, I heard about that. Okay, so if we see the birth of stars and the death of stars, and we see the birth of galaxies and the death of galaxies, or galaxies in different stages, Halton Arp showed that. Um, uh, how is it that this thing is in one way direction? How is it that we could have a big bang and everything sort of going in one direction? In fact, there was just an article today I saw that was really sad. I think I saw it on Facebook that says, oh, yeah, it was on Einstein's Facebook page, which I have been just out there pounding away and not being impolite, but pounding away with facts and in articles and all that. And they keep coming at me. In fact, I found out who's really running that page. Anyways, a different story. They came out with something about, how the universe is going to end. It's all expanding, of course. It's just going to end, right? And I think that's very funny. And anybody who I think is looking at the Big Bang or some idea or a theory, you must understand and in your theory be able to explain what looks more like not any um, explosion or not any um, big event, more like just a lot of things going on in life and death cycles of lots of stuff. We see stars go through supernova and we know all the stages it looks like. We see what happens. It throws matter out. That matter then gets together again and starts accreting and forms a new solar system. Our solar system is what, 6 billion years old? Well, the universe is way older than that. Well, in my opinion, the universe is eternal. Even if you have a Big Bang, the universe is eternal. This idea that time and all that changes. So I would say to you, from all the people I see, that if you were to look at sort of a consensus outside the mainstream of people who don't subscribe to the Big Bang, that they're going to tell you it's infinite in space, infinite in time, and things are in cycles. You can see the life and birth of everything. And imagine there are some people even saying the same thing about subatomic particles that happening. Borkert, for example, says something. I believe that no two particles are identical. There's no such possibility. But anyways, that's sort of my take on that. Again, there's no problem with having your own ideas, but be very careful. If you do have your own idea about the origin of the universe, then you should be careful to, it says, I can't understand, if you do have your own, you've got to explain these cycles and why they are why we see them, because we see them. I can't understand today's cosmology being based on trying to explain away what is not fully understood. Yeah. Very good, Tommy. I've actually sometimes said something similar, but not so elegant. So, Tommy Bird, hats off to you. If I had things to give away, I'd send you a prize. I'll have to start doing that. I don't have any Dissident Science merch, but maybe once we get our book, maybe we can have something out there. But it's like, yeah, give you my book for a prize. Oh, that's really good, huh? No, actually, what I should do is look in my back. Actually, I've got lots of copies of books back here that are we have lots of copies of. So I have more than one copy. So I should probably start doing that. Start having people giving those away to people who are say something that tickles my funny bone or my brain. It says they hide imaginary explanations of fantasy away instead of saying we really don't know. Absolutely, that's what's really amazing. When I talk to the average person, they go, "Well, then what is it?" I said, "We don't know," and they look at me like, "What do you mean you don't know? Science is supposed to tell us about everything." So, you know, Science, Stephen J. Crothers, he does awesome work. Yes, I know him. I have met him numerous times. he's quite a interesting chap, as we say. He's from Australia, and I believe he's from Australia, but he is a fighter. He's an interesting guy. If you haven't read about him, you can go to our one of our websites. Let me get it to you right here. Go to this website and you can look at the scientists there. We have a science woke is a place for people who have never thought maybe that mainstream science could be wrong and why, and we just never had it. There's no website out there for it, and written in a way that is very much like a magazine. So this is a Science Woke is a critical thinkers magazine, and it's made in a very fun and interesting way. It has scientists who are disputing major parts of standard science, standard mainstream science. Stephen Crothers is there. In fact, he has his fight where he got kicked out of the university. If you've not heard that story, go and you can read about it there. So, very interesting. Let's see here. Let's see. We have seen furthest out for calculating expansion speed, or is that for the future of telescopes? Have we seen furthest out for calculating expansion speed? Well, again, all I can say to you is I wouldn't be interested in calculating expansion speeds or even in their calculations. Can I understand them? Yeah, I've got my bachelor's of science in mathematics, so I'm pretty good at math. And I just wouldn't want to waste my time looking at it because it's not fruitful, in my opinion, since I think the evidence they give for expansion is not evidence at all, and that light that they claim light is moving. There's all kinds of things. There's a problem of even trying to think of what a galaxy would look like 13 billion. If it takes 13 billion light years for us to see that, it's now 13 billion light years further, which means that then really the universe is further. So maybe it's half of 13.87. That is that. So that's what, six and a half, six, almost 7 billion light years that we can see further. And every time we get a telescope, guess what happens, folks? And that's why I think expansion works for mainstream science. The expansion gives them a way to keep the universe at this finite number, which they want to. They're just bent on getting that number down to the hundredth decimal point of a. So, well, let me go here. I do want to skip everybody. Hawking's. Oh, sorry. I'm sorry. I'm going to get back to these with regard to my thing. Okay, space created by. Okay. Wow, there's so many of these Stephen Solves. Yeah, I'm way back here. So, here we go. We have the furthest out. Yeah, we did that one. Okay. See, no hair. Yeah, the space is created. Okay, here's one. Space was created for ether to exist. Ether was created for space to exist. Empty space does not exist. Okay, that's fine. You are an etherist. That is one theory, but I'm not an etherist. I think ether has a lot of problems. I could never really accept it myself because I see insurmountable problems, not just problems. And I think the reason people in my next video, please stay tuned. I have it all scripted out. I haven't had the time to sit here and read my script in a nice way, so I don't always speak eloquently live. That's why I do the scripted ones, and it is much more interesting. People watch scripted videos much longer, and that's my idea, is to get people to keep through a whole idea and keep their eyeballs on it. So, yep, if you're an etherist, the idea of space and ether existing, I would say non-consensual. If you need to read Glenn Borkert. He's both an etherist and he talks about space and existing things in space, and space isn't empty. I absolutely believe that space is super full of stuff. There is space in there, and that's where mass is. But regardless, you should definitely read Borkert because he is the authority on two of those. So that's cool. I was on the other channel listening to live stream. Okay. Okay, an origin of presumption is, let's see. Oh, yeah. This person saying an origin is presumptuous. Yes. Having maybe you're talking about the Big Bang there. Let's see. With regards to dark matter thing, is there anything like that we can consider shadow as part of the dark matter? Can we consider shadow a part of the dark matter? I think if you're talking about regular shadow, um, no, you can't. Again, all of these questions can be answered if you have a model for gravity, for light, and all these things, especially light. And if you have a physical model for all of those things, you're going to be able to answer these questions. So my question back to you, Authentic Max, is what model do you subscribe to, and is there a model that can actually do that? We're working on our book and our model that we have a description. So when I talk about, there's no dark matter, we have a model to tell you why things would work this way. But in this case, dark matter was invented anyways because they were too lazy to calculate Newton's gravity the way they should have. And so my first part of that answer is no. Dark matter was invented because they were too lazy to apply Newton's gravitational field to non-spherical objects, and so you can throw that away. So when we're looking at it, it's a shadow. No, dark matter, I would just throw that entire notion out. Again, that's my opinion, but I think there's a lot of people who think that as well. And plus, if Newton describes the exact same speeds, why would you have, if your model, there's Occam's razor, and that is basically the simplest wins, right? Occam's razor. And so if Newton explains it without dark matter, and Newton's 334, 30 some years old, Newton, his theories, that works just fine, then dark matter is no longer. It's all about charge. Again, charge is an attribute. We subscribe to something. It is not a real thing, in my opinion. In fact, we have models that don't need it. If you have a model that can describe the same thing without charge, and you have charge, Occam's razor again. Let's see. Hawking's black hole Big Bang doesn't work. That infinite strength gravity singularity can't begin to expand. Gravity didn't create the universe as it is in the way. Hawking's black hole Big Bang. Of course, he said black holes aren't the way he thought before he died. I can call them gray holes. The infinite point, you have what they call singularity. That's not the artificial intelligence where now we have machines that have consciousness or something like that. It's the singularity. Yeah, it's an infinite point with infinite mass. Yeah, they try to get around that by saying, well, it's really dense or whatever. But yeah, that's a problem of relativity actually, and more than anything. So infinity. Let's see. Infinity is an imaginary mathematical construct. Perpetuity is more elegant. I'm not sure what that means. Infinity is quite an interesting concept. I subscribe to it. Can you wrap your head around it? You can, in a lot of ways, wrap your head around it. So, thinking if you travel this one direction in the universe and had infinite amount of time and an infinite amount of fuel, you would never reach the end. That's one of the ways I look at it. You have infinite time, you can go infinitely on. Let's see. I definitely think our entire universe has galactic and even solar cycles exactly like cycles. It's fractal. Yep, fractal is one way. I'm not sure I get the idea of life cycles being fractals. I do think that fractals are a great mathematical model for the way we see the universe, because when I see blue and then I break down and go at the atomic level, there is no blue there at all. And so fractals are the same way. When we look at fractals as humans, we can only see a certain, resolution, and then we can calculate our way down to a more fine resolution, and those things change. I think there's a lot to be said that kind of model and that kind of thing can actually help us in the way we look at our own models and those kinds of things. So, and Laurie Gardee, I do have fractals in our book and talk about how you can use that concept. I do love fractals, by the way. I really love them myself because, mathematician. It's really cool. It's a cool way of looking at things. Whoops. I want to make sure I get. There's a lot of interesting. All right. Looking here. Plasma is alpha and omega. Plasma works and does the same things on all scales. Yeah, I think a lot of times when I hear people, especially from the Electron universe, talking about plasma, a lot of times people are trying to, again, find, oh, the universe is all of this. I think we have to be very careful. Our model, you kidding? There's an infinite amount of different particles going all the way up and all the way down. Not in our area. Well, there's an infinite amount of particles, I think, in our direction, in our plane, or in our level of the universe. But you got to be careful and sort of taking one thing and making everything out of that, and not worrying about the levels above and below it. Plasma discharges are scalable. Not much really to say on that myself. Mitch is all based on redshift, and it's B.S. Halton ARP showed redshift is not a measure of distance. Yep. If you haven't read Halton ARP and seeing red, absolutely recommend it for everybody. They're just pen period. They make up stuff and explain what they're. Yeah, I think just talking about people. Oh, David, they are just bent. Period. Make up stuff. They try to explain what they see out there. Yeah. Electric universe and expanding Earth. Yes, I think the electric universe has a lot of great work going on with them. And of course, expanding Earth. The Earth is definitely expanding. And electric universe doing some great research work as well. All right, I'll put myself up here. Either way, shockwave ether is part of occupied. Okay, another etherist. Ether is part occupied by light atom. The glass is half full. Again, etherists, no problem. One thing you would want to do, I would recommend everybody, is to try to spell ether E-A-T-E-T-H-E-R. E-T-H-E-R is a gas. And so what we do in the distant world, those people are etherists, is to spell it A-E-T-H-E-R. Just a minor point. Again, if you're an etherist, that's fine. Please explain to me the problems of like lasers. If you're an etherist, please explain a laser to me, and I'll start believing in ether a lot better. But lasers are not explainable by. It's like saying that you can send a wave in water straight for 1,000,000 miles without it spreading out very much. I can't see that happening in a medium. Electronic information can be transferred without direct contact. So, okay, this is a comment where we're starting to get into these. No offense, I'm going to say it. My own opinion. I think all this stuff. I work with computers every day. My living is made with writing. My friend and I came up with a computer programming language 20 years ago, which we use to write programs to understand human written language, and to read it and understand it like humans do. But I do not believe information. This idea of information is real. The only thing I can say is information is transmitted in waves, and that is waves of particles in our model. But information is transferred and is valuable, but it's transferred in waves. That's how we get information. That's how we see color, for instance. So that's part of the. I think. In fact, I'm going to write that down, because that we'll put in our book. Because that was one of the explanations for waves. Information and waves. Waves book. Gotta make sure I put that in the book. I talk about that. Okay. Energy is the ether. It's not particles. Well, here's some philosophical problems with that. Energy is a concept. It isn't real. If you're talking about some sort of thing that you can't get, it's not physical, then I can't even imagine things in the universe that are not physical. That's magic. I don't believe in magic. So that's my own opinion. So energy is the ether. And again, I don't. I want ethers to explain to me. I will be happy to talk about it. And here's what I'm going to say to you guys. It's going to be in my next video because I'm hearing so much ether, 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 ether. What about lasers? What about ether, which is the transmission of light? It will be also the transmitter of electricity. How does that happen? How do you keep that? In fact, that's what they're trying to do. They've had to invent a new element in the periodic table to explain using ether to explain electricity. Ether also has the problem of elasticity that's absolutely absurd. How can you have bumping? Look, here's the way I put it. People say, do you believe in ether? And the average person, I explain to them ether. Oh, I get that. I said, but here's the problem. If here's two problems that I can see that ether. The amount of information that has to be transferred through one particle. So if you have a room full of people all speaking, you cannot hear all of them and decipher. You can't get something and hear them all. It starts to get muddy. And that's not perception only. It's muddy because you can only transmit so much through a medium in all directions at all times. Whereas like in our particle model, it doesn't matter because they're particles. They just don't meet. They're just so small and there's so much time that's allowed. You don't meet. So you got that problem with ether. The other problem with ether is the literally the elasticity. And that elasticity is how is it that you're going, this particle is going to hit this particle is going to hit this particle. When you do that in sound, the other part of sound, other than getting muddy, is its transmission distance. You can only hear sound for maybe a couple miles if depending on the frequency. How is it you're going to transmit light 10 billion light years? And it's going to get to you because it's bashing one billiard ball into another to get to you. I can't see that. The other one is lasers. How can we send light out as a beam? Because you can't in a medium send anything out as a beam because the moment you disturb it, it goes out in all directions. You can't make it go in that one direction. So when people here are talking about ether, and this is ether, and I think ether's energy, and I think ether's neutrinos, I think ether's electrons, I think ether's photons, you got to answer those questions still. You can talk about it all you want, you can make your ether, but the problem is you have to be able to answer those problems. So this is a good question. Philosophically, what are particles really? Well, if you look at them even in our model of the universe standard model, you look at what you're looking at me. You're looking at me. I'm made out of atomic atoms, cells, atoms. When you get down, the atoms are mostly space. So when you try to find the atom, you get space. Well, if neutrons or the nucleus of an atom is also made of stuff, and it's mostly space, and then those things have particles, and it's mostly space. It's what I call the wispiness of mass, which infinity brings to us. So it's one of those things you're not going to get an answer to, really. Particles are a wave formation, transmission of information. Particles are a waveform. Particles are a wave formation. Oh, I see. So that's you're one of the people who say, and I'm not saying it's wrong, but you subscribe to the idea that particles are waves in a medium. Okay. Well, I think those kinds of ideas are interesting. They say they're standing waves. I need to have someone explain to me how a wave can be standing in an ether and stand there for an immense amount of time and be very immensely stable. Again, folks, in the end, if you've got a person on the street, if you've got the general population who wants to get to your idea and you've got the best idea in the world and you're going to change the universe, people are going to ask you questions. And if you can't answer basic fundamental objections to these things, like ether has, they're going to just look at you and you're going to continue to work in your world. And it's not necessarily you're going to go much with it until you can answer those questions. Some people are trying to answer those questions. Let's see, discrete energy forms. What's energy and how go? Energy is a concept again. Think about it, folks. Just think about it for a while. My goodness, so many. There we go. We know the effect of property. Trying to explain why I explain directly. Thanks most for answering my question. Cool. Good. Oh, that's nice to see. Put that up. Good for. Hey, shows worth something at least. Substrate of space. Okay. So, the substrate is space and area that constitutes perceivable environment. Okay. I'm also, for those who don't know, I am a mathematician and a linguist. I got my master's in linguistics, so I really enjoy language, and I spent the last 35 years trying to understand human language and why we have words and what they mean. The substrate is space. Now, let me tell you what's wrong with this sentence linguistically and philosophically with that phrase. The substrate, a substrate, we have that word because it is absolutely a word to mean mass. It's mean to mean something. It means matter. It's not space. It's not nothing. A substrate is something real. Substrate. That's why that word exists. We use that word for that. Now you say, is space? Space is nothing. The reason we have the word space is because we have to have a word to mean when there's nothing there. And yes, space is full of stuff, but there's still space in between, as the way we say. So, anyways, the only thing I will pick these apart. You see this? Physics police. I will police your words. Now, I'm not here to argue about what you're claiming is the way the universe is or is not. I am saying that you are saying things that are not logical. You're using words that do not mix. And no, physics and the universe are not poetic. We can't sit there and say we can call anything anything and say we have the right to. Yeah, you have the right to, but no one's going to take that as a serious endeavor in natural philosophy, or what we call physics and cosmology today. Plasma separates electrons from nucleus, so where do they both go to? I'm not sure. I don't have an answer to that. Space is a coordinate system and nothing more. Very good. I like that answer. Give them something. That's why I said, basically, Dr. Karazani, my mentor, doctor in physics, who showed Einstein wrong, special relativity wrong, very brilliant person. His work, I finally came to the conclusion that space is a three-dimensional place where matter exists, and we can move the origin, but there is no like frames. You don't have a frame for the moving train, a frame for this event happening, and a frame for the person standing next to it, a frame for the earth. There's no. There's mass moving in space, and there's no such thing as an inertial frame. All this stuff is mathematics that got in the way and invented in relativity, which is all wrong. The universe is that big thing out there. That's pretty interesting. Yeah, I mean, in the colloquial sense, and we are an amnesiac species. Yeah, that's probably true. Unfortunately, I thought ether was pronounced different. I don't know. It could be in English, and it could be very much so. I have lots of my people. Even my boss is from the UK, and they may actually say yes. They pronounce it two ways differently. Talk about your model. Dave talks about your models a bit so I can understand them better. Well, we do talk about it. If you want to know more about my father and I's model, do we have it here? Yeah, here it is. So you can go to this website, and we also have Principia Mathematica 2 YouTube channel, which we actually just did something. It was pretty interesting, talking about how flowing particles around the nucleus of atoms. My dad is finally coming to the believing what I call the polarity, and why molecules stay together in the ways they do. It's all because of the flows of the particles around the nucleus, and those flows set up the new effect. And if you don't know what all that is about, then our book's coming out on all that, but you can sort of look all that up. So I don't want to spend a whole lot of time on my father's theory, because this is more about uh, light is energy element. Light is something real. It should be something real. It should be physical. When you stand out in the sun or you get smashed by a laser and it goes through you and cuts you in half, it is not energy. It is a real thing. We just don't have a model for it, at least not yet, that we all agree on. Yeah, oh, yeah, don't believe in magic. Absolutely, I do not believe in magic. And illusions, I believe that people can make illusions. Where are we? Boy, there we go. Either, let's see, belief. Okay, here's this, so we see this again. Two photons make one electron if the energy is removed from vice versa. This comes from pair production, I believe. And this is the idea that, yes, that you can take one electron and supposedly break it up into two photons. But we have some problems. You want to know some problems with that idea? I will tell you the problems with that idea. Let's talk about the photon first of all. Primeiro, I'm speaking Portuguese. What's going on here? Tem brasileiro aqui. There's any Brazilians here. I speak Portuguese with my wife all the time, so sorry about that. It blurts out once in a while. But the two photons. Here's the problem with the photon. Photonics expert, a friend of mine I know, I've talked with him, even interviewed him for my movie, but he was chickened out because he didn't want to be associated with the idea that Einstein would be wrong, even though he said he believed that's true. He had his reputation to worry about. He's a photonic expert. He got up during one of our the conferences for our organization in the early 2000s, and he basically said this. I'm a photonic expert, and this is the experiment I want to run. I want to run an experiment where I emit the energy of 1/5 of a photon. I want to get 5 1/5 emitters of a photon, point it at a 1 photon detector, which they do have. And if that detector goes off with 5 1/5 of a photon energy, all bets are off. Everything we say about the photon is wrong. So, what's that mean? This is from photonic expert. We don't know what a photon is. So if we're talking about two photons make an electron, we're talking about things we don't know, because we don't know even really what a photon is. Both the photon and electron, also, look it up. Look at the history. We've never isolated one of those things. We've calculated them. We only have beams of light, and we have beams of electrons. We never can find them individually. So this whole idea, there's just so many things that go with that. Ether is where the math is math physical. If you're saying math is physical, don't agree with that at all. Myself, there are people who believe that. I gave an early version of our book to a friend of mine in our supercomputer. I work in the supercomputing research group. And the guy took it and set it on my desk, didn't want to read it. And I was talking about, well, what if you don't think gravity's a push from some physical force, some real mass? What do you think it is? Oh, it's tensor equations. Well, he gets that from space-time. What are tensor equations? I said, well, tensor equations aren't real. He goes, oh, of course they are. Tensor equations are physical. I don't know even how. I just say, no, they're not. Good luck, and prove I'm wrong and convince the whole world. I think it's gonna be hard, but look at sound and information on platters of waveform stuff. I'm not an ether person. Okay, I got you. Okay, hey, well, you're looking at the system call. That's cool if you're looking at a system, but again, I think one of the things again, I think what's going to happen is people, we're doing it. Some people are starting to follow suit, I think, a little bit. We're now starting to say, heck with everything. We got to describe everything as something. We've got to get away from systems and talking about, oh, the system has this and the system has this and it has this layer and this. No, what is it? Tell me physically. And what is it made out of and what is it made out of? And yes, we have models that are coming out that are doing that. So but vacuum exists and things travel through a vacuum or just don't perceive it. Yeah, Well, no, a vac, a, it's a place. It's not to say a vacuum exists. No, okay, let's step back. A vacuum is really a word that we use for pulling out what we think are molecules. So when we have a vacuum in a laboratory, it's still full of light. And if light's real, then there's something in it. So the whole idea of vacuum came from the idea that we suck everything out, and so that we don't have anything in there. But there's gravity in there, there's light in there. You can put a magnet up there, there's going to be magnetism in there. So a vacuum of space, we just like there's nothing there. Again, what we have to do is say space is a three-dimensional place where we where mass move in which mass moves. That's about all we can say. If we start trying to get any more fancy than that, we're just going to get ourselves in trouble. Is space nothing? Yeah, that's the idea. When people, there are many languages around the world. I think there's India was supposedly had 1,500 languages, but a lot of those have dropped. They're no longer there. But let's say there's 3,000 languages in human languages in the world, which is probably true. There is a word for space, and most all of them they mean nothing. So even if we know there's air there, there's space between you and me, but the concept means nothing. That's why we have it. Let's see. Laser is a point source, coherent alignment of dielectric hyaboloids of ether. No, it can't be, because ether again. Okay, then what I would say again, we're using language. Be careful there. Hyaboloids of ether. Ether is meant to describe light. Okay, ether came about because we think light looks like a wave, and we see waves in water, and we know there are waves in air. That's why ether exists. That's why someone came up with that. They didn't come up with that independent of the knowledge that we have sound and that we have waves in water. That the first people who thought of ether were using what they see around them and they hear around them. So it is light. Laser is light. Now, if you're saying that laser is hyaboloids of an ether, then you're saying laser isn't light anymore. And so it's a whole different story. So we have to start thinking about here, is this really ether? Because ether is light and laser is light. And so it's getting mixed up. Here's what happens. Here's my opinion. I'm going to give you some of my talk. Ether is a knee-jerk reaction we have that light looks like a wave, acts like a wave, and then therefore, because our intuition sees water and our intuition knows there's air, that's the way waves are. It's got to be a wave in something. It's not the only way. There's at least two other ways that you can transmit light. It can be in a lattice, and yeah, it sounds bizarre, but we could be in a solid lattice, and we're just there is arguments for that, and I've known several people who are lattice people. And then there's the particle model. We have ether, and we can do lasers. We can do all of it. That's fine. So ether is no longer the only choice. So again, folks, be careful. Here's what's going to happen. Ether's, another model is going to come along and blow ether away. Then what you're going to do? You spend all your time only looking at one model for light instead of looking at them all. And because you're married to ether, you're married to, you love your ether. It's right. It's got to be right. My intuition says that the model next to you is going to win out, and everybody's going to drop ether like a hot potato. And where are you? Are you going to fight everybody? I'm not saying that's going to happen. But I'm saying is there are other viable models. We have one. And in my opinion, it doesn't have the same problems. Here's ether. It's got all these problems. Here's the particle model for our light that my dad came up with in 2015. When he showed that to me, I went nuts. Oh, wow, that works. I'm not saying that ours is right and ether's wrong. I'm saying there's more than one. Do not get married to a model. I'm not even married to a model. I think of ether about almost every day and how that model may work or not. And I'm not an etherist. That's the way to do it, though. Don't marry yourself. Opposite of charge creates motion. Opposition of charge. What's charge? I'm sorry again, I keep repeating myself. Charge is a concept, it's not real. I agree that math messed up our perception of the universe. Yep, very good, very well put. Um, oh no, come on, Ephraim, are you telling me they've actually approved it? No, approved funding for a new CERN particle center. Okay, that's not like the Large Hadron Collider. The Large Hadron Collider, are they talking about the bigger one? Well, there's a lot of people who make lots of money of doing this. There's lots of Nobel Prizes to be won, and then people can say we found the God particle. Everything. It is a house of cards. Read Lost in Math by Sabine Hossenfelder. Read The Higgs Fake by Dr. Alexander Unziker. But any comment on that? It's sad. You know what happens is building those big things. Really, they're building it because it's prestigious. They're building it because they'll make a name. The people who are involved with it they feel like they're discovering the universe, and they're just building more unicorns. They're inventing more unicorns and pretending to find them. That's what basically they're doing. Magic is mystery we're happy to leave unexplained. Yeah, man, nice. The poet is a poet. Good. Like it, I like it. Nil, zero does not exist in the universe. It only exists in concept. Yep. Things like energy, even force. Point to force. You can point to a moving object. That's all you can point to. And it's only moving, of course, relative to where you're standing. See, is there something that form attraction and attraction and repulsion? That's okay. Maybe it's not English is not your native language. I have no problem with that. So I'm trying to read the concept, so I don't care. Between particles or something within these particles creates attraction. D and E. Yes, your model of the universe should have that in it. In our model, what we use for attraction attraction and repulsion. Attraction happens in two ways: from the Denou effect, which is more what we would call magnetic fields, attractions from magnetic fields that are flowing particles will cause attraction or repulsion, and gravitic fields, which we in our model that causes attraction. It does not cause repulsion. Again, you can't answer any of those questions unless you have a model. So I'm answering it according to our model. If you have a different model, you must explain that. So I apologize. I'm not here again to push it. The first sentence in the second part of our book says everything in this part of our book is wrong, because our model is wrong. It's just less wrong than models before it, we think. Large scale universe function scale, yeah, let's make it look like different. Okay. We're getting to the point, well, it's still people popping in and out, I'm sure, too. Again, I want to welcome all my subscribers. I see most of them are from the Dissident Science channel, and I do appreciate it. I have another video coming up in the works. It's about ether, and I am going to go for it. You know me, I will not mince words. I will tell you what I really think, because the biggest critics of even our model, my father and my model, you know who the biggest critics are? Ourselves. So let's see, space volume. So sorry to bomb your chat. Just got a great information comprehension. Okay. Oh, there's no problem there. Anyways, that is for my book. I can get that down now. We've had that up a little bit. We're coming up on almost 2 hours, so I usually like to wrap it up. Things are in the news all the time. If you want to see me ranting and raving, go to Facebook's Einstein page. I did some research, and I found out the 26-year-old who runs that page, and they work directly with with Israeli University, who makes money from Einstein. For those of you who didn't know, Einstein willed his image and his works to the university. You're welcome. Thanks for the discussion information. You're welcome. Call Call for president. Go for president. We need somebody to run who actually cares about people and not about money and greed and corporations, all that. We the people, hey, just do something for the average guy. But anyways, I was talking about Einstein's Facebook page. Turns out that Einstein's image, when he died in 1955, I believe it was, at the age of 76, I know a little bit about it because I actually interviewed a friend of Einstein's. Uh, that was pretty interesting. But regardless, yeah, he died. He willed his image and his um, theories and works to an Israeli um, university. He was Jewish, so he did that. And they were making, until 2010, they were making either the first or the second amount of most money by a dead celebrity. I think Elvis may have been first, then Einstein. Well, it's because all the images that people wanted to use, they had to pay royalties for that. In fact, the biggest royalty payment for Einstein's image was in the movie AI by Steven Spielberg, who is also Jewish, and really just gave it as a donation of $600,000 to have 3 seconds of Einstein's image in his film. In 2010, the university took 2008 or 2009, the university took to court, I think it was GM, the car company, or one of the car companies. Please don't quote me on that. They had a picture of Einstein all buff, like, with his shorts down stuff. He was like, had a tattoo of E equals MC squared and had Einstein's head on it. And they said they were using that for advertisement, which they couldn't do because they owned the rights. Well, guess what? After so many years, the rights ran out. It ran out in time for my film, which I had, of course, used it in my on my poster and all that on Einstein wrong. So, Duplicat, hey, I haven't seen you in a while. It says, Dave, are you familiar with Stellar Metamorphosis by Jeffrey? Ever shrinking bodies, stars burn out and become planets, which become moons, breaking up in comets. Hey, that's interesting. If you look, I've heard of the opposite, which is the mass increase happens and that the Earth will eventually, as it's now expanding bigger, is that eventually it will get to a point of a critical mass where all the things on the surface become gaseous, and the gaseous, it becomes more gaseous, and then it turns into Jupiter, and Jupiter is just older than the Earth, and then Jupiter keeps getting more and more mass, and it then ignites and becomes the sun, and all of Jupiter's moons, which are gaining in mass, become planets, and the cycle goes over. So Duplicat, I have actually heard both ways. Interesting. Who's to say who's right? And I'm open-minded to all of that. So, um, all right, we have just a few more minutes. 8 minutes, 7 minutes. Any more questions or comments you want to make? Again, I was talking about the Einstein's Facebook page. You can see me there. I'm actually a top. I've got a badge for being one of the top commentators on the Einstein page. You can imagine, and I have actually people. I figured out they. I thought they were real people, but they really look like fake. Um, they look like fake profiles, and they always laugh at everything I say. They make some comments, but I do believe that those people who are making their fake trolls on their own account. The people who run, there's one guy who runs it, and he works with the university who was making money off of Einstein. Now that you have 19 million people on a Facebook page and they put all kinds of stuff, it's a money making machine because Facebook, when you have that many, will put ads there, and they do, and they will pay you. So people with that many likes on their page do get money. They also got money from working with several. They've had several documentaries about Einstein. They're always trying to pump this guy up, and everybody who watches it thinks it's interesting. And then they go back to the real world and they go, Einstein's doing nothing for me. I don't see Einstein anywhere. Why do they make a big deal about it? And they go, well, you just don't understand. But what can you say? So what else? So I'm over there. I'm a top fan. That's what it's called, a top fan. And I go there, and we actually get some good traffic. I get actually subscribers because not everybody believes this Einstein stuff. So I'm constantly challenging. I'm very surprised that they leave me there. I think what their idea is, as I'm very polite, I don't call them idiot names and just make stupid comments like this is the dumbest chat. Why you a bunch of idiots running this? I don't do that. I actually make substantive things. Like one of my favorite articles is from Science Woke, where our chief scientist for the CMPS is from MIT. She got her degree in special relativity, her PhD from MIT in special relativity, and her first real world application applied that to a gyroscope made out of light called the Sagnac effect, and it failed miserably. We don't need to be specific. Relatives say light is electric and magnetic fields. Relatives say light is electric and magnetic fields. In ether theory, we could also say electric and magnetic fields are traveling through ether. Again, yeah, you can say that all you want, but you have to answer the very large and problematic questions of ether. Again, people married to the idea this is the only way you can make waves. It is not. There are different ways to make waves, not only through a medium. So, can I say everybody's married to ether? I'm going to make that. That's what I'm going to do. I make graphics for my videos. I just got a picture of one. It's going to be a bridegroom in ether, and they're going to be married to it, you know. And of course, you got all the objections sitting around. Any objection? Oh, perfect. Bridesmaid. Writing this down. Bridesmaids. Bride to ether. Any objections? Thank you, people. You give me inspired sometimes. All right, we got 4 minutes. Just a couple of things. Do some advertisement here for everybody. First of all, you can go see my documentary at einsteinwrong.com. It's $3 to rent, $10 to watch forever, as many times as you want streaming. It's on Vimeo. Why do I have it that way? Because I had investors into respect my investors. I will not give it away for free. It basically, the monies that go for it basically keep it running on the website that allows you to stream it. So it's just a matter of literally being there and available. And respecting, you know, I've had $80,000 from scientists outside mainstream who gave me money for that film. Very entertaining. You don't have to be scientists to understand or to enjoy that film. It's very entertaining. Another website you can go to is sciencewoke.org. If you're new to the idea of science outside the mainstream, you can go to that. We have a Wikipedia of over 10,000 pages of scientists, their abstracts and works, and also books. And yep, that's pretty much it. If you want to go to and see about our theory specifically, my father, who's going to be 83 very soon, he and I are working on a physics model and book coming out this fall. It's coming along very nicely. I'll give you a link to that, but you can go to his channel, and I recommend it. It's very good. He talks about the particle model and how it relates to the entire world, etc. You can go to our website for the book is there. We also have you can also get to our YouTube channel, which we talk about our theory and our book building right now. Jeff Yee, a friend of ours, has an energy wave theory. People who are more into ether-like wave theories and particles being standing waves. I love his theory. I don't believe in ether, but his is a little different. But I still think it's a great theory, a great model that he's working on. So there you go. How could I do that? I'm not married to even my own model, so don't get married to ether. I do have my own website, of course, daviddhilster.com. You can even see I've got my art there. I'm an artist, scientist, weird kind of guy, one of those people who do lots of different things. And every Saturday morning, you can go to, I don't think I have a link to that. Let me put that in here. Let me edit this one. You can go to, sorry, that wasn't what I didn't want to do. That was when we were talking about nutrition. Okay, here we go. you go to this live youtube.naturalphilosophy.org, and you can go to that, and you can get information or watch live. You can also go to live.naturalphilosophy.org and get into their waiting room. And every Saturday morning they talk about pretty heavy stuff. If you like science, but it's pretty heavy into physics and cosmology. They talk about charge and moving charge and fields, all the things that I think are times futile because but it's still interesting talk if you really enjoy. It's always a good time. A lot of people join, and you can join in and actually discuss and be on video just like we're doing here. So I want to thank the CNPS for their work that they do. I want to thank all my subscribers for subscribing and finding worth in this channel. My goal is not to convince you of anything. My goal is to make you into a critical thinker and to think on your own, not to believe anything, even what I say. But if I tell you, man, the Earth's expanding and there's a lot of evidence for it, I'm here to tell you that for you to look into that and maybe open your mind a bit and say, oh my gosh, there is a lot of evidence. I do believe that myself now. I did look at the evidence myself. So I try to point out to those things which I think are interesting, which I think hold greater truths than what we have today. And like I always say, don't trust me or anybody. Stay critical, stay thinking. I'm Dave D. Hilster, your Dissident Science. I'm your science therapist. Ciao for now. Let me see if I have anything. Thank you for what you do. Well, thank you very much. And like I said, I'm your science therapist. I'm here to get you to the promised land of becoming and staying a critical thinker. Take care, everybody, and look forward, hopefully, to my video coming up very soon. Subscribe and let other people know about this channel. All right, and hope to see you next week. I am thinking about moving it to Sunday in the morning because right now I have actually a lot of people who are in Europe who want to join in. They can't at this time. So I'm thinking about moving it to Sunday between 10 and 12. The reason to do that is on Saturday, 10 to 12, which is a really good time. Probably the best time for getting people anywhere in the world to watch, since we have a big Pacific Ocean, and that's where it would be the place where everybody would be sleeping. But it is Sunday morning. A lot of people may not be available. I think I'm going to give that a try eventually. So take care, everybody. Ciao for now.